Most people assume oysters come from the wild, pulled from remote tidal flats by small boats working at the edge of the sea. That assumption is wrong for most of what reaches the American market today. One operation on the coast of Washington state produces 115 million oysters in a single year. No wild harvest could replicate that volume. Oh, this is industrial aquaculture running on tidal schedules, hatchery science, and cold chain logistics. 115 million oysters grown, graded, packed, and shipped from a single coordinated system on the Pacific coast. This video traces that system from hatchery tank to refrigerated truck, stage by stage. If you follow water-based food production, subscribe to this channel and leave a like. It helps document operations like this one. And tell us in the comments, have you ever eaten a Pacific oyster? Or worked anywhere along this supply chain? The larvae in the hatchery tanks are already developing. The operation is already running. Taylor Shellfish Farms operates across multiple sites in Washington state, but the core of its output originates in the shallow tidal waters of Willapa Bay and Puget Sound. The operation spans thousands of acres of state-leased tidal ground. The growing cycle for a Pacific oyster begins as a microscopic larva, smaller than a grain of sand. It is produced in a controlled hatchery environment where water temperature, salinity, and algae supply are managed with precision. Inside the hatchery, broodstock oysters are conditioned to spawn. Water temperature is raised gradually to trigger release. Eggs and sperm enter the same controlled tank, and fertilization occurs within hours. The larvae swim freely for approximately 2 weeks. During that time, they feed on cultured microalgae grown in separate tanks within the same facility. Water quality checks occur multiple times per day. At a stage called setting, the larvae are ready to attach to a hard surface. Oyster shell, called culch, is introduced into the tanks. So each larva attaches and begins its transformation into a juvenile oyster known as spat. Spat are transferred to upweller systems, vertical tubes that push nutrient-rich water upward through mesh-bottomed containers. The current keeps the spat suspended and delivers a constant food supply. See, after several weeks in the upwellers, the juvenile oysters are large enough for outdoor transfer. They are moved to tidal flats or suspended grow-out systems in the bay, depending on the farm's rotation schedule. Willapa Bay is one of the least polluted estuaries on the Pacific coast. Its cold, nutrient-dense water supports accelerated oyster growth. Water quality is tested continuously by both the farm and state regulatory agencies. On the tidal flats, oysters are planted in rows on the substrate. Twice daily, the tide recedes, exposing the beds. Farm workers move across the flats during these low-tide windows to inspect, rotate, and manage the crop. The work is timed entirely by tide tables, not clock schedules. A crew may begin at 3 a.m. if the tide runs low at that hour. The cycle repeats regardless of weather or season. Suspended culture methods are also used. Long lines anchored offshore with hanging mesh bags or cages containing oysters at depth. This approach keeps oysters submerged during all tide cycles, accelerating growth. Each mesh bag holds a specific seed count. As oysters grow, they are thinned and redistributed into larger bags at lower density. Crowding slows growth and increases mortality. Spacing is calculated, not estimated. Technicians monitor shell condition, meat fill, and mortality rates across different zones. Data collected from each grow site is compared against historical yield curves to project harvest timing. Pacific oysters at Taylor Shellfish typically reach market size, approximately 3 inches, in 18 to 36 months, depending on water temperature, food availability, and grow-out method. The timeline varies by site. Harvest begins when sample testing confirms the oysters meet size and condition standards. A crew loads flat-bottom boats with equipment and moves to the designated grow bed in the early morning hours. On the tidal flats, workers use rakes and shovels to gather clusters. On suspended systems, bags are pulled by mechanical davit or by hand onto the boat deck. The work is physical and continuous. Once on deck, oysters are separated from clusters by hand. Mud and debris are rinsed with seawater. Individual oysters that fall below size are returned to the water for continued grow-out. Filled harvest bags are transported to the dock by boat. The cold chain begins here. Oysters must remain cool and moist from the moment of harvest. Delay in this stage has direct consequences for shelf life. At the dock receiving station, incoming harvest is weighed, logged, and tagged by harvest location. Harvest location traceability is required by federal regulation. Every bag carries a tag with zone, date, and harvester ID. Oysters move from the dock into a covered processing facility. The building maintains near ambient cool temperatures. Workers in waterproof aprons and gloves begin sorting by hand at large stainless steel tables. Size grading separates the harvest into commercial categories. Oysters too small for market are set aside for return. Those meeting standard dimensions advance along the processing line toward packing. Tumbling machines are used to clean shell surfaces and break off irregular growth. The tumbling action also promotes a more rounded shell shape, a characteristic that affects both presentation and shucking ease. After tumbling, oysters pass through a second visual inspection. Workers check for shell integrity, look for cracks or abnormalities, and remove any that do not meet the batch standard. Oysters destined for half-shell consumption receive particular attention. Shell cleanliness, meat-to-shell ratio, and visual symmetry affect premium pricing. These are sorted into a separate grade category. A portion of the harvest is directed toward shucking, mechanical and manual separation of meat from shell. Shucked oyster meat is packed in brine solution, chilled rapidly, and containerized for food service accounts. The shucking line operates at sustained pace. Each worker processes a set number of oysters per hour. Yield per shucked pound is tracked and reported. Speed and consistency are both measured. Live half-shell oysters are packed into mesh bags or waxed cardboard boxes with gel ice packs. Box weight, oyster count, and grade are labeled on each unit. Temperature at packing is logged. Refrigerated storage holds finished product at near freezing temperatures. Oysters must remain alive until point of sale. Shelf life for live oysters in cold storage runs approximately 10 to 14 days post-harvest. Cold chain logistics begin at the loading dock. Insulated, refrigerated trucks are loaded directly from cold storage. Departure time. Truck temperature and destination are recorded before each truck leaves the facility. Distribution reaches restaurant accounts, wholesale distributors, and retail seafood counters across the United States. Some volume moves to export markets in Asia and Europe via temperature-controlled air freight. The export process requires additional documentation, health certificates, cold chain records, and foreign regulatory compliance. International orders are prepared in separate staging areas within the processing facility. Water quality monitoring runs parallel to all production stages. State shellfish safety programs test growing waters weekly. If a water quality threshold is exceeded, harvest ceases immediately until clearance is issued. Biotoxin monitoring is a separate regulatory layer. Filter feeding shellfish can accumulate algal toxins from surrounding water. Testing occurs at state-certified labs. No harvest moves forward without clearance. The hatchery operation continues independently of the harvest cycle. While mature oysters are being graded at the processing line, the next cohort of larvae is already growing in the hatchery tanks. Taylor Shellfish maintains its own hatchery, giving the operation control over seed supply. This reduces dependence on external hatcheries and allows the company to manage genetic selection and larval timing. Algae production supports the hatchery directly. On-site algae cultivation tanks grow specific microalgae species used as larval feed. Water chemistry in these tanks is adjusted daily based on growth measurements. Byproduct from shell processing is not discarded. Oyster shell is collected, dried, and sold back into the hatchery supply chain as culture used for setting new larvae. The material circulates within the system. The farm employs several hundred workers across its operations. Hatchery staff, tidal flat crews, boat operators, processing line workers, cold chain coordinators, and regulatory compliance personnel. Seasonal variation affects staffing and harvest volume. Summer months see increased output as demand rises. Winter harvests are smaller but continue year-round. The operation does not have an off-season. Equipment maintenance runs continuously. Boats, upwellers, conveyor lines, and refrigeration systems are serviced on rotation. A mechanical failure at any stage affects output. True preventive maintenance schedules are followed strictly. Water temperature data from multiple bay zones is tracked daily. Temperature affects oyster metabolism, growth rate, and spawning triggers. Unusual temperature events prompt adjustments to harvest timing and grow-out planning. Oyster mortality from predation, particularly from invasive species and native starfish, is managed through mesh enclosures and periodic predator removal operations conducted by tidal flat crews. The 115 million figure represents annual harvest output across all product forms: live half-shell, shucked meat, and seed oysters sold to other farms. Each category flows through a different processing and distribution path. The seed oyster operation is itself a revenue stream. Surplus hatchery production is sold to smaller shellfish farms across the Pacific Northwest. Taylor Shellfish functions as a regional seed supplier in addition to a producer. At the close of a harvest day, the final boats return to the dock as the tide rises. The gear is rinsed and staged for the next cycle. The bay surface returns to its uninterrupted state. Either the last trucks of the day depart the processing facility. Boxes are stacked in temperature-controlled trailers. Manifests are sealed. By the time the trucks reach the highway, the next harvest is already being planned. 115 million oysters, produced in a system that runs on tidal schedules, us water quality data, hatchery cycles, and cold chain logistics. Continuously, year after year, the boxes are sealed, the trucks are on the road, the water in Willapa Bay is already moving again. Under this video, there's a subscribe button. It's a small action, but it helps document how water becomes food at scale. If you found this system worth following, leave a like. And tell us, where are you watching from? Have you ever worked in aquaculture or seafood processing?